Alright, so this is going to be wPrime 1024M on my Xeon W3570, and we're testing the Koolance CPU-LN2 version 2. I tested the first version about 7 months ago or so, and the dry ice performance was pretty damn good. This time around though, it looks like we're getting slightly better base temperatures. I'm going to attribute that to the much better base design. And this time around we're going to test 1024M at 5.1 gigahertz. This isn't the maximum the CPU would do, but I'm just trying to get a baseline here. So I'll fire it up. Let's make sure we've got... you'll hear that noise. It's going to be me stirring the dry ice pot every so often. But here we go, and here you can watch the left side. This is the IHS, and this is the pop base. You can see the temperatures are off a little bit. We're off by about a degree or so. I think this probe actually is a little bit less accurate than the probe on my Fluke. But for our purposes, it's close enough. Alright, so I'll start it off. You can see already, the IHS temp is already crashing. I wouldn't say crashing, but we're dropping down. I would expect, maybe a 10-degree delta between the two. There we go. Looks like it's close to stabilizing. I just threw in a little more dry ice to try and give it a little boost, but those are pretty good temperatures, I would say, at least for my very little or very slim dry ice experience. Well, you can't really see the wPrime benchmark, but we're at 55% right now at 85 seconds. Just to give you, I guess, a little comparison information, last time around with the CPU-LN2 Rev2, we had IHS temps around -51 Celsius, but we were also at only, I think, 4.9 gigahertz. So, it's a modest improvement in IHS temps, but also a much better improvement, I guess, in the frequency scaling that we achieved from colder temperatures. Alright, there we go. We just completed it. Completed the benchmark at 150 seconds, so 2.5 minutes to complete. Next up will be, I believe, 3D Mark Vantage. No, the 3D Mark 05.